Hi, in this video I'm going to take you through how to answer an AQA P2 paper. In this case it's the foundation paper from May 2014. So we start with question 1. Figure 1 shows the life cycle of a very large star. Use the correct answers from the box to complete the sentences in figure 1. Gas and dust join together to become a protostar. The star is stable as A. So I'm going to use my memories of the stages of a star and write in that it's a main sequence star. Okay, the star expands to become a red supergiant. That's telling me that this is a very large star. That's reminding me what it said at the top. The outer layers of the star explode as a, and that's a supernova. The core of the star shrinks and a black hole is formed. Okay. Figure 2 shows the forces acting on the star when the star is stable. So we've got forces pulling inwards and forces pushing outwards. When a star is stable, the forces pushing outwards are something the forces pulling inwards. Well, if it's going to be stable, it's not going to be changing, so the forces must be balanced. Okay, question 2. Figure 3 shows a distance time graph for a person walking to a bus stop. So we've got the first section. For the first 150 seconds, they travel 300 meters. Then they don't travel any distance for the next 50 seconds, and then they travel another 200 meters. So which one of the following statements describes the motion of the person between R and S? Well, their distance doesn't change, so they must be not moving. Another person walking at constant speed travels the same distance to the bus stop in 200 seconds. Complete figure 4 to show a distance time graph for this person. Okay, so the total distance to the bus stop was 500 meters, and they're doing it in 200 seconds. So we want to have a point there. They're going to start from 0, 0. And if I just get my line tool up, we draw a straight line. You guys would use your rulers for this, between those 2 points. Moving on to part B. A bus accelerates away from the stop at 2.5 meters per second squared. The total mass of the bus and passengers is 14,000 kilograms. Calculate the resultant force needed to accelerate the bus and passengers. So I'm going to look at my equation sheet and find the equation that links force, mass and acceleration. So force is mass times acceleration. So our mass was 14000 times our acceleration was 2.5. And if I just get my calculator, I can work that out. Is 35000. So 35,000 newtons. Okay, electricity. So you need to know the circuit symbols. Draw one line from each circuit symbol to its correct name. So from like year 7, we know that that top one is a lamp, nice and simple. Now, this triangle with a line here, that tells us it's a diode, but these arrows here represent light. Arrows often represent light in these circuit symbols. So we're looking for something with light in, and we're looking for something with diode in, and that's going to be the light emitting diode. And then here we've got the rectangle that shows us it's a resistor with 2 arrows coming in showing us there's light. So that's going to be the light dependent resistor. Okay, figure 5 shows 3 circuits. The resistors are identical. That's going to be important later on. And each of the cells has a potential difference of 1.5 volts. Use the correct answer from the box to complete the sentence. The resistance of circuit 1 is something the resistance of circuit 3. So if we look at circuit 1, there's 1 resistor and circuit 3 has 2 resistors. We know they're identical, so circuit 1 must have half the overall resistance. Okay, then it wants us to calculate the reading on voltmeter 2. We know that each cell is 1.5 volts. We've got 2 cells there, so that's 3 volts. And voltmeter 2 is just connected to the only resistor in that circuit. So that must be using all of the 3 volts. So it must be 3 volts. Which voltmeter, V1, V2 or V3, will give the lowest reading? So here we've got 1.5 volts and 1 resistor, so that's going to be 1.5 volts as well. 3 volts and 3 volts. And here we've got 1, 2, 3, so that's 4.5 volts, but that's divided by 2 resistors, so that's going to be 2.25. So we were asked which one gives the lowest reading. That's going to be circuit 1. Okay, a student wanted to find out how the number of resistors affected the current in the series circuit, and we've got the diagram of the circuit they used. Ammeter to measure the current, resistor, switch and cells. They started with 1 resistor and added more resistors in circuit. Each time a resistor was added, the student closed the switch and took the ammeter reading up to a total of 4 resistors. Here are 3 of the results. What variable did the student keep the same? So to make sure this is a fair test, what I'd be looking at is the number of cells. So we're not supplying any more energy. So number of cells. The bar chart is not complete. The result of using 4 resistors is not shown. Complete the bar chart. Okay, so we've gone from 1 to 2. So we've doubled the number of resistors and the current has halved. We've gone from 1 to 3, tripling the number of resistors, and it's gone down by a third. So we want a quarter of the overall resistance. So try and keep our bars the same size as the original. You don't need to shade it, that will be enough. Try and get it along the line as well and use a ruler. What conclusion then can they make from the bar chart? If we've got more resistors there, the current is decreasing. And you have to give the full details. You can't just say the current decreases. Okay. Question 4. Paintball gun is used to fire a small ball of paint called a paintball at a target. Here is a picture of someone just about to fire a paintball gun. The paintball is inside the gun. What is the momentum of the paintball before the gun is fired? So if I look at my equation sheet, it tells me that momentum is mass times velocity. I don't know the mass of the paintball, but I know that before it's fired, it has no velocity. It's not moving. So my momentum is going to be 0. And my reason is going to be the paintball isn't moving. Or the velocity is 0. Okay, the gun fires the paintball forwards at a velocity of 90 meters per second and the paintball has a mass of 0.003 kilograms. Calculate the momentum of the paintball just after it's fired. So we've already looked at this equation. It tells us that momentum equals mass times velocity. So 0.003 times 90, 0.003 times 90 in my calculator gives me 0.27. Okay, the momentum of the gun and paintball is conserved. Okay, so that means that overall it stays the same. The total of momentum of the gun and paintball just after the gun is fired will be something the total momentum of the gun and paintball before it's fired. Well, that's going to be equal to. That's what conserved means. If I could spell, that would help. Fortunately, there aren't any marks for spelling. So, figure 9 shows a helium atom. Which of the particles in the atom is not charged? Okay, so we know that an electron is negative, a proton is positive, and a neutron is neutral, which means it's not charged. Which two types of particle have the same mass? Well, you need to remember that electrons are really tiny compared to the others. The proton and the neutron have the same mass. And then we're asked the atomic number. Now, atomic number is the same as the proton number. So if we look at the diagram, we've got 2 protons in there. And our reason is going to be it has 2 protons. Alpha particles are one type of nuclear radiation. Give one other type, so we know alpha, beta and gamma, so you can say either beta or gamma. I'm going to go with beta. Okay, use the correct answer from the box to complete the sentence. The difference between an alpha particle and a helium atom is that the alpha particle does not have any, that is, electrons. The alpha particle is just the nucleus of the helium atom. And which one is a property of alpha particles? They don't have a long range in air. They only take about travel about 10 centimeters. Highly ionizing is true. Will pass through metals. No, they're stopped by skin and paper, so that's not going to be it. They are highly ionizing. Doctors may use nuclear radiation to treat certain types of illness. Treating an illness with radiation may also harm a patient. Okay, the risk from treating a patient with radiation is that the radiation may something healthy body cells. Harm, damage. Let's go with damage. Draw a ring around the correct answer to complete the sentence. Radiation may be used to treat a patient if the risk from the radiation is something the possible benefit of having the treatment. So obviously we want more benefit than risk, so we want the risk to be much smaller than the possible benefit. Okay, plugs. So we've got a diagram of a plug and a cable. Which terminal connects to which wire? Right, so the first thing I know is that the fuse has to be with the live wire, so the live must be terminal C. The top pin is the earth wire, so that's going to be B, and that leaves neutral as A. Name a material that could be used to make the case of the plug. We want something that's an insulator. Let's go with plastic. Could also go with rubber and get the mark. Okay, there's an electric drill and an extension lead. The drill is used with the extension lead. The drill is used for 50 seconds. In this time, 30,000 joules of energy are transferred. What is the power? So we know that energy is equal to power times time. We need to rearrange that. So we want power on its side, so we need to divide by time to get rid of time on that side. So divide by time, and that cancels out. So power is going to be equal to 30,000 divided by 50. I'm going to put that in my calculator. And that gives me 600. So my power is 600 watts. Second drill is used with the extension lead. The power of this drill is 1200 watts. The instructions for using the extension lead include the following information. Do not go over the maximum power because the lead may get hot. Right. If the lead is wound inside the case, it can have a maximum of 820 watts, and if it's outside the case, 3,100 watts. So why would it not be safe to use the drill with the extension lead if the lead was left wound inside the plastic case? So we're probably going to get a mark for saying the power of the drill is more than 820 watts. This will cause the extension lead to get hot. And what's the effect of it getting hot going to be? It could damage the insulation. This could damage the lead, making it unsafe. Okay, moving on. We've got information about 3 different electric drills. We've got a person going to buy one of the 3 drills. The drills cost the same. You use the information to decide which one the person should buy. So, all of them have the same power output. That makes it easier to compare. So, all of them are going to be producing the same amount of energy usefully. But our input's going to be different. So, we want the one with the lowest input because that's going to save us the most money. So, that's X. So, we want to use our scientific knowledge in this question. So we either want to say it wastes the less energy or the least energy, or it is the most efficient. Okay. Figure 12 shows a slide in a children's playground. A child of mass 18 kilograms goes down the slide. The vertical distance is 2.5 meters. What is the decrease in gravitational... Okay, figure 12 shows a slide in a children's playground. We've got a child of mass 18 kilograms going down the slide with a vertical distance of 2.5 meters. We want to calculate the decrease in gravitational potential energy as they slide from the top to the bottom. So the equation we find on the equation sheet is GPE, gravitational potential energy, equals mass times G, which is the gravitational field strength, times H, which is height. So 18 times 2.5 times 10. Which gives us 450. The slide is made of plastic. Explain why the child becomes electrically charged. Okay, so when 2 insulators rub together, we get friction between them. So there is friction between the child and the slide. And the effect of that friction is it causes electrons to move from one surface to the other. To be transferred. You don't need to say which way they're transferred because we're not given that information. Okay, going down the slide causes the child's hair to stand on end. What conclusion about the charge on the child's hair can be made from this observation? Okay, so if the child's hair is standing on end, that means it's all pushing apart from each other. So the hairs must all have the same charge. And we know that because it is repelling. The hairs are repelling. Why would the child not become electrically charged if the slide was made from metal? Well, that's because it's a conductor, and when you've got a conductor, the charge can travel through it to the ground. So we can just say metal is a conductor of electricity. Okay. Figure 13 shows the horizontal forces acting on a moving bicycle and a cyclist. What causes force A? Friction, gravity, or weight? Now, we can rule out weight and gravity because they're both downward forces towards the centre of the Earth, which just leaves friction. Now, usually we've been thinking about friction as the force opposing the motion, but actually, because we look at where the arrow is, it's between the bike and the ground, we can see that it must be friction. Friction actually helps objects move forwards because as we push backwards, the friction with the ground pushes us forwards. What causes force B? That's a simpler one. That's going to be air resistance. Okay, this is our 6 marker looking at our spelling, punctuation and grammar, so we need to be careful here. Figure 14 shows how the velocity changes during the first part of a journey along a straight and level road. The force applied to the pedals is constant, so our forward force is going to be constant. Describe and explain, in terms of forces A and B, why the velocity of the cyclist changes between points X and Y and between points Y and Z. Okay, so between X and Y. So, at this point, the velocity is increasing all the way. So, that tells us that the forward force must be being greater than the backward force. Let's just remind ourselves which way they are. A is the forward force. So, force A is greater than force B. So the bike is accelerating. And its velocity is increasing. But force B is getting bigger. Force B is getting so the acceleration is getting less. And I know that because the graph is getting less steep as we go along. Okay, between Y and Z, force B is becoming as large as force A. So they cancel out. The resultant force, that's the word for the overall force, is going to be 0. So there's no acceleration. To clear that double C up to make it look less like an E. So there is no acceleration and speed stays constant. And there's a fancy name for that, which is terminal velocity. Okay. The cyclist used the brakes to slow down and stop the bicycle. The constant braking force of 140 newtons stopped the bicycle in a distance of 24 meters. Calculate the work done and give the unit. So looking at my data sheet, work done is equal to force times distance. So the force was 140. The distance is 24. 140 times 24 equals 3,360. Now work done is a type of energy, so our unit is joules, capital J for joules. When the brakes are used, the bicycle slows down. The kinetic energy of the bicycle, if it's slowing down, it decreases. At the same time, the something of the brakes increases. So that kinetic energy is being turned into heat. So what's happening to the brakes is their temperature is increasing. And that's it. Thank you for watching. I hope this was helpful, and goodbye.